With C#1, we can create a simple switch statement. Starting C#8, the pattern matching is available, and we can use the discard symbol as the default parameter, or even throw exception in it. C#9 adds relational patterns like less or more, and logical patterns like and or operators. And pattern matching can be used not only with the switch statement. For example, we have the hasMeeting method, and we can rewrite with the contains keyword with C#1, but with C#9 we can reduce it just by using the is keyword and or logical operators. And similarly, we can rewrite the isLetter or dot method with the new C#9 pattern matching style. Personally, I like the previous style in this method. With C#8 we can rewrite the switch of tuples to an inline switch or expression switch. And we can use positional pattern matching for tuple values here, and long numbers can be in C# separated by underscore symbol just for clarity. Records with C#8 allow to use property matching, so we can use the property names to match some statements. And we can use positional matching with records as well, and of course mix both solutions. Property matching also is working with usual classes and their properties. And if you want to have the positional matching for a class, we need to implement the deconstruct method. So after the implementation, we can see that we can use the positional matching as well in this class. With properties, it is more clear what property you're actually deconstructing. We can deconstruct properties out to variables with classes as well, if we implement the deconstruct method. But it doesn't make much sense because we can just use directly the properties. At the same time, with tuples, it makes sense, because with standard tuples you have properties under name like item 1, item 2, item 3, and it's not convenient, but after the deconstruction we can use the variables. We can use the var keyword to introduce a new variable with the property matching, as well as in the positional matching. With the when keyword, we can add condition statements and even extend this with some logical operator like and sign. And of course, to use the variable in the interpolation. You can reference nested fields or properties with C#8, but with C#10, it is possible to use the extended property. C#11 introduced list pattern matching. You can use it with arrays as well, and you can check the exact elements of the array. For the next statements, we will use only the true statements. You can check for the first element match, for the last element match, the exact third element of an array having exactly the 5 elements. You can apply the logical and relative pattern match statements. And you can use the var keyword to deconstruct individual elements out of the array, as well as the inner part of the array. Now let's consider type pattern matching. With C#1 we can create a switch to get a type from an object. We can also use the typeof operator in the if statements. With C#8 we can directly switch by type, but we need to add the discard sign. With C#9 there are many improvements. First, there is no need for the type underscore sign. Then you can use the type variable. The type switch we also can use the property decomposition. For example, a string has the length property. We can use logical as well as relative pattern matching. With the when keyword we can use multiple statements as well. Let's remove the integer I case for clarity. It is possible to mix the property decomposition, the when statement, and logical patterns, but it is less clear than just pure when statement. And of course, it's convenient to use some function in the when statement. Pattern matching is working not only with tuples or records. You can use it with the usual class and its properties.